Imagine a time long ago, billions of years in the past. Our solar system, as we know it, didn't exist. Instead, there was a vast cloud of gas and dust floating in the emptiness of space. This cloud, called a nebula, was made up of tiny particles left over from the explosions of ancient stars. It was a cold and dark place, but within it lay the seeds of our solar system. These particles, though small, were drawn to each other by a fundamental force in the universe, gravity. This invisible force pulled the particles together, causing them to clump and cluster. Over vast stretches of time, these clumps grew larger and larger, attracting more and more gas and dust. This process, known as accretion, marked the first step in the formation of our solar system. As the cloud continued to collapse under its own gravity, it began to spin faster and faster. Think of a figure skater pulling their arms in as they spin. The tighter they get, the faster they rotate. This spinning motion caused the cloud to flatten into a spinning disk, much like a pizza dough being tossed in the air. At the heart of this swirling disk, the densest collection of matter continued to grow. Gravity pulled relentlessly, drawing in more and more gas and dust. The pressure and temperature at the center of this growing mass became immense. Atoms, once content to drift in the vastness of space, were now forced to collide with incredible force. This intense pressure and heat triggered a process called nuclear fusion. In nuclear fusion, hydrogen atoms, the simplest and most abundant element in the universe, are forced to come together under immense pressure, fusing to form helium. This process releases a tremendous amount of energy in the form of light and heat. This marked the birth of our sun, a giant ball of burning gas that would become the anchor of our solar system. With the sun ignited at the center, our solar system began to take shape. The intense heat and light from the newborn sun pushed outward, creating a boundary between the inner and outer regions of the disk. This boundary would play a crucial role in determining the fate of the planets that were about to form. In the swirling disk surrounding the young sun, the process of accretion continued. Dust grains, drawn together by electrostatic forces, began to stick together, forming larger and larger clumps. These clumps, in turn, attracted more dust and gas, growing steadily over time. As they grew, their gravitational pull increased, attracting even more material from the surrounding disk. Over millions of years, these clumps grew from tiny dust grains to objects the size of mountains, known as planetesimals. The solar system at this stage was a chaotic and violent place, with countless planetesimals colliding and interacting with each other. Some collisions were destructive, shattering planetesimals back into smaller pieces. Others were constructive, merging planetesimals together to form even larger bodies. The fate of these planetesimals depended on their location within the disk. In the inner region, closer to the sun, the intense heat and solar wind blew away much of the lighter gases, leaving behind mostly rocky and metallic materials. This is where the inner, rocky planets, Mercury, Venus, Earth, and Mars, would eventually form. In the heat of the inner solar system, 4 rocky planets emerged from the maelstrom of planetesimal collisions. Mercury, the smallest and closest to the Sun, endured a relentless bombardment of impacts, shaping its cratered surface. Venus, shrouded in a thick, toxic atmosphere, experienced a runaway greenhouse effect, trapping heat and making it the hottest planet in our solar system. Earth, our home planet, found itself at just the right distance from the Sun, allowing for the presence of liquid water, a crucial ingredient for life as we know it. Mars, once a warmer and wetter planet, lost much of its atmosphere to space, leaving behind a cold, dry, desert world. Despite their differences, these four rocky planets share a common origin, formed from the same materials in the inner region of the early solar system.